think we should be good. Okay, so it starts off pretty easy. It says to graph the image of point R, which is at 4, 6, after the transformation. So it gives us point R, and this one's not working. This one's not either. Dude, did somebody steal my lead? Y'all so mean. Okay, I got one. Okay, so point R is right here. It says we're going to perform a translation, x plus 4, y minus 4. X plus 4 would mean you're going 4 to the right, and you count 4, and it's not even on the graph. What the heck? The reason why is because they're counting by 2s on the graph. So when you count over 4, you're counting to there. So it'd go to the right 4, and then down 4 to get R prime. Okay, next one, graph the image of triangle RTW after the following transformations. We're going to do a translation and then a rotation. So starting with a translation, it says x minus 1, y plus 1. On this graph, they are counting by 1, so we can do x minus 1, y plus 1 to get w prime. X minus 1 up 1, r prime, and then t prime. And there is our image after the first transformation. Then we have to take that and perform the rotation. It says a rotation of 270 degrees counterclockwise from the origin. Counterclockwise was the positive way, so it would be plus 270 degree rotation. These transformation rules, I'm going to keep them up through Friday, which is when our test is. So they will be up here. If you look 270, we're going to follow this rule, which is y negative x. And then as far as the points go, we have to pull the points off the graph for w, r, and t. So the points that we graphed are at negative 5, 2. R is at negative 3, 4. And t prime is at negative 3, 2. And no, there's no shortcuts to this, but these were all over the EOC 2 years ago, so practicing them. Then for the 270 degree rotation, counterclockwise, it would rotate all the way over here into like this quadrant. I'm going to manipulate the points. W double prime, R double prime, T double prime. I can hear the wrapper, put it away. Jeez. Okay. Then I need to change these points. And then graph them. Then there is our final image. Okay, the next problem is similar. We're going to do a translation first and then a rotation. So starting with the translation, it's x minus 2, y minus 2. The graph is counting by 2, so we're going to move it over just like 2 and 2 to get p prime, r prime, q prime, and s prime. So there's the translation. Then for the rotation, it says 270 degrees clockwise. There is a trick here. So the counterclockwise was positive 270. 270 clockwise is going to be negative 270 degree turn or rotation. Negative 270, we look at our chart, we don't have the rules for that. Negative 270 is the same as positive 90. So like if you're going 270 in this direction, it's the same as going 90 degrees in this direction. So we're going to use the rules for positive 90 degree rotation, and that rule is negative yx. So taking all of our points P, Q, S, and R, and then taking these points those are the points we graphed after the translation, and now we're going to perform the rule to get the points for the rotation. And then the last step, I'm going to graph these 4 points. Okay, and for 4 and 5, they're actually the easier ones on the page, which is nice. Graph the image of point G from 6, -6 after the following transformation. So they already put the original point G, and now we need to do the translation, x minus 2, y minus 2. So it would fall right here. And the graph is counting by 2, so that's why it lands there. And then the next one for point T, they put point T on the graph for us. It's x minus 6, y minus 2. So T prime would land right here. Okay. And now we're going to move down to the bottom. So the bottom is where we introduce dilations, which is what we're learning about today. We have had one lesson on dilations already, so that might help us out a little bit. But these are all dilations. Okay, so I'm going to kind of like teach as I'm explaining how to do these examples. It says graph the image of rectangle KLMN after dilation with a scale factor of 2 and centered at the origin. So scale factor 2 centered at the origin, and then they have this rectangle right here, kind of hard to see, you might want to trace over it. Okay, here's a couple important things. It says that this dilation is centered at the origin, which is important. Most of the examples that you will do are centered at the origin, but sometimes if they're trying to challenge you more, they'll say it's not centered at the origin, just so you know. Scale factor of 2 means that this shape is going to get twice as large. And a dilation is like when something grows or shrinks. So a scale factor of 2 means it's going to get bigger, like twice as big. With a dilation, that center is important because not only is the shape getting twice as big, these points are getting 2 times the distance from the center of dilation. So from point L to the origin, it's this far. If we double that length, we will get L prime. And we're going to do that for each one of the points. So if we double the length from the origin to M, we will get M prime. Double this length to get N prime. And so our dilated image is right here. And this image is similar to the original, meaning everything is proportional. So all the side lengths, this side length would be twice as long as this side length. Okay, the next one, number 2, shows like a different way that it might be presented. So this one is a dilation, a scale factor of 1/4. 1/4 means that the shape is going to get smaller, like a quarter of the size. It says that the dilation is centered at the origin, and then here is our shape here. Notice how it's not really like on top of the origin, but the dilation is still centered at the origin. What that means is like these strings that are attached to each corner, they will shorten by like 1/4. So the actual image after the dilation will actually look like this. Where's my, I had it drawn out. Hold on. This is you don't have to draw this because it's kind of like a lot to like cram in there. But if you look at it, you have the rectangle, and then the smaller version is right there. It's closer to the origin, and it's 1/4 the size. So that's that. Okay. Then the next example we're going to do together is right here. This one right here. Graph the image of this quadrilateral after a dilation with a scale factor of 3 centered at the origin. So centered at the origin again. This shape is going to be 3 times as large. With the last example, we just made this distance like 3 times that. With this example, you can't be that precise. So we're actually going to use the points to do the dilation. So we're going to take the coordinates of D, E, F, G. Okay. So point D is at -3, -3. E is at -3, 3. F is at 2, 3. And G is at 2, 0. So those are the points of the original. So what we're going to do now, since it gets larger by a scale factor of 3, we can actually take all these points and multiply them by 3. You can only do this trick or hack when it is centered at the origin. Otherwise, you'd have to find distance and like multiply everything by 3. But when it's centered at the origin, you can just multiply your coordinates by the scale factor. So D prime, E prime, F prime, and G prime, we're just multiplying everything by 3. So this would be -9, -9, -9, 9, 6, 9, and 6, 0. And then I'm going to graph the new coordinates. There we go. So the new shape is 3 times the size as the original. Also, these points are 3 times the distance from the origin as the original points. And I know we're getting tired at this point, so go ahead and cross out number 4. We're just going to skip that one, and then we're going to move on to the workbook. So actually make sure your name's on this, pass it up, and then take out the workbook from yesterday, those workbook pages. I'm going to 5 minutes, you're timing me? Well, this is timing me, we'll see. Okay, so the first example, it says that the center of dilation is 3, and then the scale factor right here is 2. So we are going to enlarge this shape and make it twice the size, but we're going to use that center of dilation and draw a line to each corner. This here has to double in length, so just kind of eyeballing it, I'm going to double it in length. Okay. Then to each corner, so this length will double as well. And then this length will double as well. And again, I'm just eyeballing it as best I can. And so our new enlarged triangle is right here. Okay, the next one. This time it has a scale factor of 1/4, meaning that the shape is getting smaller. So anything larger than 1 is going to get larger. Anything less than 1 is going to get smaller. So this length right here, I'm going to go to like 1/4 mark. And again, just kind of eyeballing it. I think 1/4 might be right there. And then this length here, 1/4 of that might be right here. This length, 1/4 right here. And then the length here, 1/4 of that might be right here. And I should get a square that is 1/4 the size of the original. And 1/4 the side means the side lengths are going to be 1/4 the size of the original. Okay, and next, number 3 and 4. For these examples, it says determine whether k to k prime is an enlargement or reduction, then find the scale factor of the dilation and x. Okay, so from k to k prime, k prime is definitely larger, so this is an enlargement. Then x right here, well, if this whole length is 7 and this is 5, then x must be 2, so x equals 2. Then we will find the scale factor. Before, when we did scale factor, we used the side length and we made a ratio with the side length. This time we're using the distance from the center to find scale factor. So for scale factor, it's going to be the new image over the original. So we're going to take the length to the new image, which is 7, and put it over the original, which is 2, and we get 3.5. So scale factor is 3.5, which seems accurate because in enlargement, this would have to be greater than 1. Number 4, going from k to k prime is much smaller than the original, so this time we have a reduction. To find x, 5 minus 2 is 3, so x equals 3. And then again for scale factor, it is the new one over the original. So the new one is only 2 away, so that would go on top. And then the distance from the center to the original is 5 units. So scale factor here is 2/5 or 0.4. Same thing. Okay. 5 and 6 we aren't going to do because the examples were actually better on the other worksheet. But leave them blank because if you get these on your homework, you could just use the graph to draw it out if you need to. Then here, number 1 and 2, fractions, lovely. Chill, we got this. Okay, we're not gonna get all like specific here, but a scale factor of 3/2, that's larger than 1. 3 divided by 2 is 1.5. So that means that this triangle would get larger and further away from that center. And then number 2, the scale factor is 2/3. That's less than 1, so this is going to get smaller and closer to that center, like that. Number 3, these are just like the ones we did. K to k prime is larger, so this is an enlargement. See what x equals. Well, 15 minus 10 is 5, so x equals 5. And then scale factor. Again, new over the original. The newest one is 15 away from the center, and the original was 5 away. 15 divided by 5 is 3, so our scale factor there is 3. Also, that scale factor would apply to side length as well. So if you knew that that was a scale factor, you could take side length and multiply it by 3 to get the side length of the other one. Number 4, from K to K prime, it is an enlargement again. X, this time 1 plus 2 is 3. And then for scale factor, our newest one is 3 away, and our original is 2 away. 3 divided by 2 is also equal to 1.5, so either of those are the scale factor. Okay, again, the graphing practice we already did, but just keep in mind some of these might show up on the homework, so if you get a graphing one on the homework, just use these graphs to graph it out. And then number 7, estimate, I hope I'm saying that right, enlarged a 4-inch by 6-inch photograph by a factor of 5 halves. What are the new dimensions of the photograph? Okay, do you remember how to multiply fractions? 4 times 5 halves. When you multiply fractions, you put the whole number over 1, and then you just multiply across. 4 times 5 is 20. 1 times 2 is 2, and that gives you 10 inches. That's for the shorter side. Then the longer side, 6 times 5 halves. 6 times 5 is 30. 30 over 2 is 15 inches. So your new photograph will be 10 inches by 15 inches. And that's it. Did I make the 5 minutes? Hold on, I need to give you instructions. No, I didn't make the 5 minutes. Okay, so you're going to do homework 9-6 on Schoology. The computers are working. So you're going to use a computer. Then when you're done with the homework, you will work on Khan Academy. If you have all 10 Khan Academy done, you can get your phone. So just ask if you get all 10 done. Yes. Yes. Okay, let me stop recording too.